Yeah, so basically what I discovered is that in the IFS, there is a multicolor system that this computer, that this 3D printer uses. In the screen, let me see if we can focus right here. So basically, when you are setting up here and you are setting the color for your filament, based on this grid in here, based on the color that you select in here, for both for the source and the target color or material that you are using, is that it will determine the purge volume that I will use. I have to test yet what it does when you change material, for example, from PLA to PTG. So now I just tested based on the color. But for example, if we try as I read some Reddit threads uh, in the FlashForge subreddit. So basically, if you put, for example, all the colors to black, the purge is minimal when you change from color to color. I mean, you can put whatever color you want on the IFS, but you're telling that all of them are black. You just, when you are sending your print, your G code to the printer, you just select based on the channel, on the IFS channel, that you put the different colors. So it will think that it's changing from one color to the same color, and the purge will be minimal. But if you do that, the same thing, but changing from black to white, as you set it up on the IFS here on the printer, then the purge will be max, the max purge that it could do, because it will try to purge as much as possible to clean the nozzle. Okay, so for our first test, we're gonna do a regular uh, purge test. We're gonna go from black to white, and also we're gonna set the flushing volumes here to 1 and recalculate. So it's the regular flushing volumes that we calculate, and we're gonna set, I'm gonna slice this and send it to our printer. So as you can see here, I set up the flush volumes so it can be visible here on the AD5X. If you don't have this, I will share the link where I saw the conversation in GitHub. But basically, what you have to do to enable this column, I spent more time than I wanted to admit figuring it out. So if you have this issue where you don't see the flush filament, I know now that why it's not visible is because the FlashForge team didn't put it in there because they are actually not using these values here. But if you want to have them there anywhere anyway, what you have to do is you have to go to the printer, and then in machine G code, you go to the change filament G code, and here you everything that you put in between flush start and flush end that does actually an extrusion will count towards the waste. In this case, we are using also another commented G code, so this actually does nothing. It just is used for by the slicer to calculate. We are putting external purge, all these variables that are the different purges that it made, and basically it embeds this code into the generated G code, so the slicer can read it and calculate. So once you have that, you have this column visible. So here is saying that we are gonna get like 69 0.69 grams of purge because there is only one filament change. Uh, I know because of the test that I already done that this is not doing anything. So, but it's interesting to see it there anyways. So we're gonna send this to print, and as you can see in the IFS, we have the colors as they are supposed to be. So what you're gonna do is black to black, white to white. Then after we done this test, we're gonna do it, but we're gonna set the IFS to both, to as if both were black. So let me send this. It's supposed to last 7 minutes. So see you in 7 minutes. Okay, so the print finished. As you can see here, there is no transition. The color is clean, and this is because we didn't make any change on the IFS, even though we can see that in the slicer we set up the flushing volumes, but as you will see in the next test that we're gonna do, that's not what is affecting. So if I am right, then if we set the flushing volumes to 0, we should see the transition here. Notice also that we disable the prime tower, so there's no prime tower anywhere. Um, the purge, the purges that we have here are this. Okay, so here you can see there is no color change or fading here. We can see in the purge volumes, this is the initial purge volume. We were using pink before, so you can see the transition from pink to black before starting the print. Here you can see when the filament color change, you can see the transition very clear here, from white to gray to very white to totally white before continuing the printing here. So now we're not gonna touch anything here on the IFS. We're gonna leave it as is, and we're gonna change in the slicer the purging volumes to 0. So if the slicer is doing anything, it should affect the amount of purge that we see here. Now we're gonna go here again to prepare. We are going to go to flushing volumes and set the multiplier to 0. That will cause all the values to go to 0. We're gonna slice again and send it to the printer. The same, we set black to black, white to white. And we're gonna wait for 7 minutes more. As you can see here, the flush amount column went away. That's because we set the flushing volumes to 0, so it doesn't make any sense for it to be there. I'm gonna send it. See you in 7 minutes again. Okay, as you can see here, we just did the test with the flush volume set to 0, and you can see that with the flush volumes on the slicer, and this here is with the flush volume set to 0. You can see the initial purge on the left of each test. On the right column, you can see the transition from black to white in the purges, and the actual test on the right on both cases, and you can see they are identical. So there is no bleeding and no transition here on the test side. So now we're gonna do a test, but setting here on the IFS, we're gonna go here and we're gonna set the number 3 that is white as black. So once we do this, we're gonna send it, but we're gonna assign it to the same numbers: 1 for the black, 3 for the white. But now that the EFS believes that both are black, you will see the difference. So here basically what we're gonna do now is to assign the filaments. We're gonna send it again, and we're gonna assign the filaments the same as we did on the previous test. So to do that, we check the flushing volumes. You see that it's still 0, and now we are gonna send it to print. Here we assign the black to the channel 1 that we know that is the black one, and we assign the white to the channel 3 that even though here appears as black, we know that is the white one on the IFS. So we send it, and now we wait for around 8 minutes again. Okay, so in this last test, you can see this is the initial purge. This is the purge for the color change. And you can actually see here on the test how it starts like a little bit darkish and start going clear towards the end. So you can see here with the three tests that we just did how it starts. These two are basically the same amount of purge and the same uh, transition or lack of transition. And here you see we have the same initial purge, but then we have half of the purges for the color change, and you can actually see how it transitions from like a light gray to actually white. It's more clear when you put it next to the first from one of the first two tests, and you can see the color difference right there. So this demonstrates that we are not actually using the purge amount of the slicer, but it actually calculated itself based on the color that you set here on the IFS system. So what can we do? So basically what we can do is no matter the colors that we put in here, we set all the colors to black in this case, because you know black is the color that does the transition faster too. So because of it's the strongest color that we could use basically, or the darkest color we could use, and what we do is that the amount that we need left for it to purge, for example in this case with our latest test, we take it here to the light, see it more clearly. With our latest test we can say that it finished doing the transition at around, let's say, let's see if we can see. Let's say the transition is fully done at 300. So we put that amount to purge on the tower. And that actually saves us a lot, because if we go, when we go to the slicer, we actually are putting there like 600, 580 or something millimeters cubic. Cubic millimeters. So that's the only way we have to a little bit control the purge. For the stronger color transitions, for example, from black to dark blue, or from black to red, or from red to orange, or colors that are similar, we don't need to put as much purge. But there will be an initial purge. That's, I think, the minimal purge that we could have. This is like half a gram actually. I try to weight it, but the balance that I have here is not precise enough for this amount, but it's like half a gram. Okay, so we just saw that changing the IFS the color of the filament on the AFS is what actually affects the purging towers, the purging volume. So what we can do to to have some certain kind of control from here from the slicer. So one of the things that we can do is enable the prime tower and go here and switch the prime volume. Let's try to do 300 millimeter cubic millimeters, and try to slice the plate and see what happens. So of course you're gonna need a bigger prime tower, but another thing that you can do is like create another object, create a solid object. Could be another model that you want to print, or simply you can create a primitive here like a cube, and go to the objects configuration and just click on here and say, or go to multi-material here and say flush into this object in fill, or flush into this object. Now, if we also go here and set for this object the infill or the sparse infill to 100%. So that way, for each layer, we'll have to do a 100% layer on this infill. And of course, we set it to the color that we actually well, it's not actually the color, because it will take whatever color you need to a color change of. Another thing that you need to take into consideration is to make it the same high as your print. In this case, it's only the first layer, so it's 0.2 millimeters. So we go to the scale, we disable uniform scale and set here 0.2 millimeters, because we only need it for the first layer, and we slice. So that way, if you're using a STL, a model from the internet, just make sure that the size of the height of the model is similar to what you are actually printing. So in this case, we're gonna try first with only the prime tower. I think is all that we need to use for this one. But you know that if the prime tower is just not enough, you can just set up other object and flush into that one. So once we slice, we get this, and we're gonna do the same print again. This is our final test and see how it goes. So black is on the number 1, white is on the number 3, but we are telling the IFS that it's actually black. So we reduce the purge to the minimum and send the rest that we need to actually clear out the color to the prime tower or the purge tower. So this one will take 8.5 minutes. So see you then. Okay, as you can see here now with the transition, it's gonna print a prime tower to flush an extra 300 cubic millimeters of filament. So that should flush out and finish doing the color transition, a clear and clean color transition. Well, it's actually 300 cubic millimeters plus the tower's brim, because this is the first layer, but you get the idea. And now it moves to the test. So while it prints the test, you can see here that, well, the shadows don't help. Let me see if we can. Okay. So we see a little bit here. I don't know if it can be appreciated with the shadows, but we can see here a little bit of the transition of color done in the tower, and then we can see that the color here on the test is much cleaner at the start. So here in our last test, we see that we have the same amount of purge, but in this case we also have the purge tower, which help clean a little bit more the filament before going to the actual print. I don't know if it can be appreciated, but for example, if we move this here closer, we can see that this one starts darker than the second one, than the last one. You can see here how it starts like light gray and go all the way to white. In this case, you can see that the colors start lighter here. It's still a little bit of black in there, but not as much. But you can also calibrate this on the purge tower. You can see here that it's still cleaning here on the purge tower, and you can see that part of it also went to the brim. but that's one way that you can control the amount of purge. So we can go from this to 2/3 of the consumption. I think we have a savings around 70% of 30%, so we're just doing 70% as much. With the tower, we do a little bit more. The disadvantage that this method has is that I cannot set up the purge amount in the tower per color or per color transition, so it will be the same amount no matter from which color to which color you are transitioning. So you will try to put it to the highest needed for the more extreme transition that you have in your model. And you could also reduce this number by using a sacrificial object or a purge object, so it get the waste instead of just throwing it away. And you can see here, this, just a recap, this is with the flash volumes and setting the colors in the IFS as black and white. This is with the same, the colors as black and white in the IFS, but the purge volume set to 0. There's no difference whatsoever in between these two. This is setting both colors on the IFS to black, and the purge volume set to 0, the same. And this is with the exact same, but just adding the purge tower here and setting it up to purge 300 cubic millimeters in the purge tower.